Hi everyone. In this video we are going to prove another trigonometric identity involving the three interior angles of a triangle. I have already posted 3 videos and this is going to be the 4th video, and after this I am planning to post another 3 or 4 videos and then we will be done with these identities. So let's take a look at the identity that we are going to prove today. The identity is like this. Cosine of A plus cosine of B plus cosine of C is equal to 1 plus 4 times sine of A over 2 times sine of B over 2 times sine of C over 2. That's the identity that we are going to prove here today. It is of course a conditional identity where A plus B plus C is equal to 180 degree, because the assumption is that they are the three interior angles of a triangle, and also A over 2 plus B over 2 plus C over 2 will be equal to half of pi or pi over 2, and from there we can say C over 2 will be equal to pi over 2 minus the sum of half of A and half of B, and also A over 2 plus B over 2 will be equal to pi over 2 minus C over 2. To prove the trigonometric identity, we are also going to use a few basic trigonometric formulae, and let's review them real quick. We know that cosine of C plus cosine of D can be written as 2 times cosine of C plus D over 2 times cosine of C minus D over 2. Also, we know that cosine of C minus cosine of D can be written as negative 2 times sine of C plus D over 2 times sine of C minus D over 2. We are going to use these two concepts, and also we are going to use a couple other concepts. We know that cosine of pi over 2 minus theta is equal to sine theta, that is the complementary ratio, and similarly sine of pi over 2 minus theta will be equal to cosine of theta. And also we know that sine of a negative angle is equal to negative sine of that angle. So sine of negative theta is equal to negative sine of theta. Using these concepts we are going to prove this conditional identity. So let's get started with the proof. Here the left hand side is equal to cosine of A plus cosine of B plus cosine of C, and from here we are going to do a few rounds of transformation and then finally we will arrive at the right hand side value. Now from here, can we convert the first two terms into a product form? Then that will be 2 times cosine of A plus B over 2 times cosine of A minus B over 2 plus cosine of C can be written as 1 minus 2 times sine squared of C over 2, because we know that cosine of theta is equal to 2 times cosine squared of theta over 2 minus 1, and also this can be written as 1 minus 2 times sine squared of theta over 2. That's from the half angle formula. So we are going to use this particular concept here, that cosine of theta can be written as 1 minus 2 times sine squared of theta over 2. So this cosine of C can be written as 1 minus 2 times sine squared of C over 2, and from here we can write it as 2 times cosine of A plus B over 2 can be written as pi over 2 minus C over 2. So we can say this is nothing but cosine of pi over 2 minus C over 2 times we have cosine of A minus B over 2. Next we have plus 1 minus 2 times sine squared of C over 2. And if we simplify this further, then we can write this as 1 plus 2 times cosine of pi over 2 minus C over 2 can be written as sine of C over 2. That's the complementary ratio. Times we have cosine of A minus B over 2, and then we have minus 2 times sine squared of C over 2. And from here you can see we have some common factors, and they are actually like this. We have 2 times sine of C over 2, that can be taken out as a common factor from both of the terms. So we can say this can be written as 2 times sine of C over 2 times, from the second term here we are going to be left with cosine of A minus B over 2 minus sine of C over 2, and from here we can write it as 1 plus 2 times sine of C over 2 times cosine of A minus B over 2 minus sine of C over 2 can be written as pi over 2 minus sum of A over 2 and B over 2, and this can be written as 1 plus 2 times sine of C over 2 times cosine of A minus B over 2 minus sine of pi over 2 minus theta is equal to cosine theta. So this will be actually cosine of A plus B over 2. I'm simply writing A over 2 plus B over 2 as A plus B over 2. And since it is sine of pi over 2 minus that angle, so that will convert into cosine of that angle, right? Now let's simplify a little more. So from here we can say this is equal to 1 plus 2 times sine of C over 2 times cosine of C minus cosine of D can be written as negative 2 times sine of C plus D over 2 times sine of C minus D over 2. So I'm going to use that formula here. So this can be written as negative 2 times sine of c plus d over 2. Now what is c in this case? Well, I can say half of a minus b over 2, that is the angle c, plus a plus b over 2, that is the d angle, we can assume that is the d angle, times sine of a minus b over 2 minus a plus b over 2. And let's simplify this. So this will be 1 plus 2 times sine of c over 2. And if we bring the negative 2 from within the bracket to the outside, then we can actually write this as negative 4 times sine of c over 2 times we have sine of half of a minus b over 2 plus a plus b over 2. So that will be sine of a over 2. And then the other factor is looking like sine of negative b over 2. And this can be written as 1 minus 4 times sine of c over 2 times sine of a over 2 times negative sine of b over 2, because sine of negative theta is equal to negative sine of theta. And now we can clearly see that this is going to be 1 plus 4 times, because the negative 4 and the negative sine of b over 2, that negative and negative becoming positive here, so that would be 4 times sine of a over 2 times sine of b over 2 times sine of c over 2. There are 3 factors there, right? So I'm going to rearrange and write them directly like this: sine of a over 2 times sine of b over 2 times sine of c over 2. And that's exactly what we needed to prove. That's our right hand side. So this is actually equal to right hand side, and hence we have proved the identity. So we started with cosine of a plus cosine of b plus cosine of c, and we have been able to convert that into this form, which is 1 plus 4 times sine of a over 2 times sine of b over 2 times sine of c over 2. In the next video, we are going to see similar trigonometric identity involving the tangent ratio. I hope everything made sense in this video. Thank you for watching. See you in the next video.